Hello and welcome to our Calculus 2 practice final evaluation. Okay, so we'll be looking at a variety of questions designed to help you prepare for a Calculus 2 final exam. Okay, let's start off with our first problem here. We're using a disk method to find the volume of the solid generated. Okay, we have a function y equals x squared plus 1. Okay, so x squared plus 1, you'll note is our parabola, the y-intercept of 1. And we will be bounded by y equals 0, x equals 0, and x equals 1. Okay, so it'll be a region that looks like this. And we're going to be revolving this about the x-axis. Okay, so let's start off. We know we have our integral. It'll be from 0 to 1. Pi times our function squared. Okay, so our function will be x squared plus 1. Okay, so what we can do is pull out the pi outside the integral. And we can square our function. So you'll do x squared plus 1 times x squared plus 1. You'll FOIL it. So you'll have x to the fourth plus 2x squared plus 1. And this we can integrate using our power rule term by term. So we'll have x to the fifth over 5 plus 2x cubed over 3 plus x. And now we can plug in our limits of integration. One to the fifth is 1. 1 to the third is 1 times 2 is 2 plus 1 minus 0. They'll all be zeros. Okay, so we can simplify, get a common denominator of 15. So this will be times 3, so 3 over 15. 3 times 5 will be 15, so 2 times 5. And then this will be 15 over 15. Add them all up. 25, 28, so we'd have 28 over 15 pi. Okay, let's take a look at our next one. Okay, finding the arc length of a curve. Okay, so to get the arc length, we need to remember that we need to have a derivative, call it f prime of x, call it dy dx. Okay, but that's important for our formula. So to get the derivative, we would take 3/2 times 2/3 of x squared plus 1. Reduce the power by 1, so now we have 1/2 times 2x. These would cancel. So we have square root of x squared plus 1 times 2x. Okay, we're going to be integrating between 0 and 1. And this will be the square root of 1 plus our derivative squared. Okay, so we'll have 2x times x squared plus 1 to the 1/2, and all this will be squared. Okay, so let's simplify it. We have 1 plus, we're going to square this quantity. So the 2x squared will be 2x times 2x, so 4x squared. And squaring the square root, that would just give us x squared plus 1 by itself. Okay, we can FOIL the 4x squared into the x squared plus 1. So that gives us square root of 1 plus 4x to the 4th plus 4x squared. Okay, we could rearrange this. Four x to the 4th plus 4x squared plus 1. And if we look at this carefully, this is something we could factor, and it factors nicely into a quantity squared. Okay, so if we took the square root of 4x to the 4th, that would be 2x squared. Square root of 1 is 1. And then we have a quantity squared, and you can always double check that by FOILing it out. Okay, but this is what we end up with. And that works out nicely so that we can cancel the square with the square root. And now we could just integrate term by term. Okay, so we would have 2/3 x cubed plus x. Plug in 1. If we plug in 0, we get zeros. So we just plug in 1. So that gives us 2/3 plus, and then make this 3/3. So we get an arc length of 5/3. Okay, let's take a look at our next one. Integrate by parts. Okay, so integrate by parts, set up our u and our dv. So u would be x, dv would equal e to negative x dx. Remember, the u function you want to choose as something you could easily take the derivative of, and the dv function you want to choose something that you could easily integrate. And if you need to, do it repeatedly. Okay, same thing with the derivative. So here we have du would equal dx. From dv we're going to get v, so integrate it. So negative e to the negative x. Okay, now we're going to follow the formula for integration by parts. uv minus integral v du. Okay, so uv, so x times negative e to negative x, that would be, put it together, negative x e to negative x minus integral of v du. So that would be negative e to negative x dx. Pull the negative outside, so we have a plus integral e to negative x dx. When we integrate e to negative x, then we will have minus e to negative x, and then plus c. And that's it. Okay, let's take a look at our next problem. The integration with trig functions. Here we want to account for the chain rule component. We want to rewrite one of the functions as the form of another one. Okay, for example, we could go back to our trig identity, sine squared x plus cosine squared x equals 1. If I were to solve this for cosine squared, I would minus the sine squared both sides. So I would have cosine squared x equals 1 minus sine squared x. Okay, so that's what we would do. We'll start off with sine cube x. Cosine cube we could just split apart to say cosine squared x times cosine x. So now we would replace cosine squared with 1 minus sine squared. So sine cubed x, 1 minus sine squared x, that would be our replacement. Okay, we can distribute the sine cubed into our 1 minus sine squared. So sine cubed x minus sine to the 5th x and then we can distribute cosine x to both terms as well. So what we could do actually is split apart, have it as a as if we have two integrals Okay, and so what does that mean? We could treat both of them as if the u is the sine, and then du would be the cosine. Okay, so it's like we're doing a u cubed du and a u to the 5th du. So that means if we increase the power, we would have 1/4 u to the 4th minus 1/6 u to the 6th. Now just replace your u. So we have 1/4 sine to the 4th x minus 1/6 sine to the 6th x plus c. Okay, our next problem appears to be a trig substitution problem, integration with trig substitution. So what we do typically is try to recognize what substitution we would be making. Okay, this appears to be a sign substitution. So we would have square root of 4 minus x squared as the bottom leg. This leg would be x, and our hypotenuse would be 2. Okay, so our x would be equal to 2 sine theta dx will be equal to 2 cosine theta d theta so we could rewrite sine theta as saying sine from the triangle is opposite over hypotenuse, so x over 2. Okay. Alright, so let's start with our trig substitution. We have x squared, so that's going to be 2 sine theta squared, so that will be 4 sine squared theta. Dx would be 2 cosine theta d theta. Denominator 4 minus x squared again, so 4 sine squared theta to the 3/2. Okay, now we have the 4 sine squared theta, 2 cosine theta. Now the 4 we could pull aside, and we know that this 1 minus sine squared will be cosine squared. Okay, so we could just go right to 4 cosine squared theta to the 3/2. And so if we're looking at 3/2, the 2 is telling us to take a square root. So we could take a square root first. So if we take a square root of 4 cosine squared, we have 2 cosine theta. And because we took the square root, now we're left with the cube. Okay, so noticing we have a 2 cosine theta on top and we have 2 cosine theta that's being cubed on the bottom, we can cancel one of the 2 cosines. Okay, so we're left with a 2 cosine theta squared on the bottom. Okay, so that means we have 4 sine squared theta d theta. The denominator, we have 2 cosine theta, which is being squared. So let's square it. 2 times 2 is 4. And then we have a cosine squared theta. The 4's will cancel. So we have sine squared over cosine squared. That would just be tangent squared. So tangent squared, we could use an identity to replace. So that would be secant squared theta minus 1. Right? Those of us who remember, we cannot integrate tangent squared on its own. But we can integrate secant squared. Right? So the integral of secant squared will be tangent theta, and integrating 1 will just be theta. And so now going back to our triangle, we can now identify what our function is in terms of our original variable. So always want to go back to the original variable that was presented. So we were in terms of x. So we had a tangent theta, which will be opposite over adjacent. Okay, so x over square root of 4 minus x squared minus theta. So we have a sine theta is equal to x over 2. So if we apply inverse sine to this, we will get theta and then inverse sine to x over 2 would be our theta. Okay, so we would have inverse sine of x over 2 plus c. And that's it. Alright, our next one, evaluating the integral. Okay, it looks like we could factor the denominator. This will turn into a integration with partial fractions problem. Okay, so we would have (3x plus 11) on top, and then for our denominator, multiplies to -6, adds up to -1. We have -3 and a +2. Okay, so let's focus on our fractions. This will be a over x minus 3 plus b over x plus 2. So that means that a over x minus 3 we would multiply by x plus 2. And then the x plus 2, this fraction would be multiplied by the other denominator, x minus 3. Okay, so let's set it up. We're going to distribute the a to x plus 2 plus distribute the b to x minus 3. So we have ax plus 2a plus bx minus 3b, and this will all equal the original numerator, 3x plus 11. Okay, so our x to the firsts, looking at our x terms, we would have ax plus bx, so that would be a plus b, and that's going to equal our x term, which is 3x. So we could say a plus b equals 3. Our constants, we have 2a minus 3b, and those constants will equal positive 11. Okay, so what we could do then is we can try to solve this system. I can take the first equation, multiply by -2, have negative 2a minus 2b equals negative 6. And then I can add them. 2a minus 2a, that will cancel, there's our elimination. Then we would have negative 3b plus negative 2b is negative 5b. And 11 plus negative 6, 11 minus 6 is 5. Divide by negative 5. So we have b equals negative 1. Oops. B equals negative 1. Then we can solve for a. Let's plug into our first equation we have there. A minus 1 equals 3 plus the 1, so a equals 4. Okay, so now let's go back. Now we have a is 4 and b is negative 1. So this is what we end up with. And that means we could easily integrate here. These would both be ln's. So we have 4 ln of x minus 3 minus ln of x plus 2 plus c. Okay, let's take a look at our next one. Okay, we're integrating in the form of an improper integral. Okay, so it means we have to look at where the integral will be improper. On this interval from 0 to 3, we notice if we had a 3 in the denominator, that would give us undefined. Okay, so between 0 and 3, as our interval is approaching 3 from the left, so from the minus side, we would get it undefined. So we would say limit as b approaches 3 from the left, so 3 from the left hand side, integral 0 to b of 6x squared dx over the cube root of 27 minus x cubed. Okay, so now we could try to integrate this. Keep in mind that we could rewrite this as a exponent. It will be to the 1/3, but it's in denominator, so we could bring it to the numerator as a negative 1/3. Okay, so we could have 27 minus x cubed to the negative 1/3 and then we have the 6x squared dx. So we could try integrating with u substitution here. Our u would be 27 minus x to the 3rd our du would be, if we take the derivative, this would be negative 3x squared dx. So we have a 6x squared dx, so this is good. We can multiply by -2 both sides. And so that would give us -2 du equals 6x squared dx. Okay, so that means we could have limit as b approaches 3 from the left, and then we can make our u substitution, u to -1/3, and then we have a -2 du. The -2 I could put in front of our integral. And so I can easily integrate this. So u, I'm going to just add 1, so adding 3/3 would be 3/3 minus 1/3 is 2/3. U to the 2/3 we would divide by 2/3 or multiply by 3/2. Okay, so the 2's would cancel. We have a -3. Okay, plug back in for our u. (27 minus x cubed to the 2/3). Okay, so we'll plug in b and we'll plug in 0. Minus -3 times 27 minus 0 cubed to the 2/3. Okay, so now as we take the limit as b approaches 3, alright, as b approaches 3, so we end up with 27 minus 27. This would approach 0. Minus a negative will be positive. 27 minus 0 is 27 to the 2/3. So remember, when we do these fractional exponents, you can take the denominator and do the root first instead of squaring. Because then if you do the squaring first, then you have to cube root a larger number. Okay, so instead of doing that, take the cube root first and then square it. Okay, so cube root of 27 is 3. And then we're going to square the 3 to get 9. 9 times 3. And we end up with 27. And that's it. Okay, number 8. Number 8, you have to recognize the pattern. Okay, we have if we said, for example, u is the sine, then du would be cosine. And we have that. So this will be du over 1 plus u squared. Okay, so that's our arc tangent. Right? We should all recognize that as our arc tangent. So that becomes our arc tangent of u plus c. Substitute back in. So arctan of sine x plus c. And that would do it. That's what you guys would call light work. Right? Warm-up set. Alright, let's take a look at our next one. Okay, integral tan x over cosine squared x. We could say this is the same as tan x over times 1 over cosine square x. 1 over cosine squared is the same as secant square x. And so now we have our tangent and we have our secant squared. So it's in the form of a u and a du. Okay, so if the u is tangent, du is secant square x dx. Okay, so we would have u du. So integrating that, we would get u squared as 1/2 plus c. Substitute back in. So 1/2 tangent square x plus c. Okay, determine if the series converges or diverges. If it converges, find the sum. Okay, so the key here is to split this apart into two series. We have 2 to the n over 5 to the n plus summation 3 over 5 to the n. Okay, the first one, we have them both terms being raised to the n, so we can say this is 2/5 to the n. The second one, we cannot say that they're both to the n. So here's one way to do it. We could say this is 3 times, and then we could have the 1 on top. So 1/5 to the n. Okay, so now both of these are in a geometric series form. Remember, for geometric series, if absolute value of our common ratio is less than 1, we have a convergent geometric series. Okay, in this case, both ratios are less than 1. Okay, so therefore we could use the formula to get our sum of a geometric series. First term over 1 minus r. Okay, so the first term in the series, we have a 2/5 to the 0, so that'll be 1. And so we would have our sum equal to 1 over 1 minus r, and our r is 2/5. So that gives us 1 over 5/5 minus 2/5 is 3/5. 1 divided by 3/5 would be 5/3. Okay, for our first term in this second part, we would have 3 times 1/5 to the 0. So that's 3 times 1, which is 3. So we have 3 over 1 minus 1/5. So 3 over 5/5 minus 1/5 is 4/5. So 3 divided by 4/5 is 3 times 5/4. So that gives us 15 over 4. Okay, and we have a plus in between, so we will add these two fractions together. Common denominator of 12 multiplied by 4, 5 times 4 is 20. Multiplied by 3, 15 times 3 is 45. Add them together, and we get 65 over 12. Okay, let's take a look at our next one. Okay, previous version had this as the direct comparison test. Now direct comparison, remember we would set this as our AN. We would come up with our BN to compare to. Take our dominant term from the numerator, compare to the dominant term in our denominator. So we have n over the square root of n to the fourth, which would become square root of n to the fourth is n squared. And n over n squared would reduce to 1 over n, which we know by p series this diverges. So it might be challenging to compare a direct comparison, because you know that with direct comparison that if you have a divergent series, that AN would have to be greater than or equal to BN. Okay. And then you might ask, well, how do we know AN is greater than or equal to BN? To make it a little simpler, let's use a limit comparison test. Okay, we already have what we're comparing to, and our limit would be of AN over BN. And the rule is if we get a finite limit, whatever BN is doing, AN will also do the same thing. Okay, so let's do that. Let's take our limit then. So we would have limit as n goes to infinity of n minus 8 over square root of n to the fourth minus 5n plus 4. We would divide by 1 over n or multiply by n over 1. So we have a limit. You can multiply the n times n and n times 8. So we have n squared minus 8n. And now let's take the limit. So we're going to divide everything by, well, in the denominator we could divide by the highest term, which will be n to the fourth. And that's inside the square root. When it comes to outside the square root, we could divide by n squared. So that means we're left with 1. This would reduce to 8 over n, which will go to 0. This will be 5 over n cubed, which will go to 0. 4 over n to the fourth would go to 0. And this will be 1. We have 1 over 1. which is a finite limit. So therefore, we would say that AN also diverges by limit comparison test. Okay, 12. Use the ratio test. And does the series converge or diverge? Okay, so for a ratio test, remember we would take a limit as n goes to infinity of the an plus 1 term over the an term, and then that would give us our rho. So if rho is less than 1, we converge. If rho is greater than 1, we diverge. And if rho equals 1, we're inconclusive, so then we need to use a different test. Okay, so let's do it. We have limit as n goes to infinity. We'll have our next term, so n plus 2 plus 1 will be n plus 3 factorial over 3 to the n plus 1 times n plus 1 factorial. We would divide by the an, the original, or we could multiply by its reciprocal, so 3 to the n times n factorial over n plus 2 factorial. Okay, let's split apart and simplify a little bit. N plus 3 factorial would be the same as n plus 3 times n plus 2 factorial. 3 to the n plus 1 would be 3 times 3 to the n. And n plus 1 factorial would be n plus 1 times n factorial. And now comes my favorite part, we get to cancel. N plus 2 factorial would cancel. N factorial would cancel. 3 to the n would cancel, top and bottom. So what's left? Limit as n goes to infinity. And what do we have left? On top, n plus 3. On the bottom, 3 times n plus 1. You could distribute the 3, so 3n plus 3. Here we could divide everything by n. Or you could take the leading coefficients, that ratio. So this will be a 1, this will be a 3. This limit will go to 0. This would also go to 0. So we're left with a 1/3, which is less than 1. So therefore we would say that our series converges by the ratio test. Okay, find the first 3 non-zero terms in the Taylor series. Okay, Taylor series, we have to, let's write our function first. 1 over 4 minus x. This is the same as 4 minus x to the negative 1. Okay, let's get its derivative. So that would be negative 1 times 4 minus x to the negative 2 times the derivative of the inside, which will just be negative 1. So that gives us negative 1 times negative 1. That would cancel. 4 minus x to the negative 2. Okay, let's get the second derivative. So that would be negative 2 times 4 minus x to the negative 3 times the derivative of the inside, which is negative 1. Negative 1 times negative 2 is a positive 2. So 2 times 4 minus x to the negative 3. So all we're doing is setting up our functions so that we get our coefficients in our Taylor series. Okay, so this is the same as 1 over 4 minus x. So now it's about a equal 2, so f of 2 would be 1 over 4 minus 2, so 1 over 2. Okay, this one becomes 1 over 4 minus x squared, denominator. So that means f prime of 2 would be 1 over 4 minus 2 squared. So that's going to be a 2 squared is 4, so 1/4. Okay, this one rewriting as 2 over 4 minus x quantity cubed. So that means we have 2 over 4 minus 2 cubed, which is 2 over 2 cubed is 8, and then that would reduce to 1/4. Okay, so we have our coefficients. We're going to plug in. We know we're centered about a equals 2. Okay, well the first term would just be the 1/2, just the coefficient by itself. We have 1/2 plus, we have 1/4 times x minus 2. And this will be over 1 factorial plus 1/4 x minus 2 squared, and then this will be over 2 factorial. So we'll simplify it then. That would just be 1/2. This would be 1/4. And 1/4 divided by 2 will be 1/8. And so that would be our 3 terms. Okay, let's take a look at our next one. Radius of convergence and interval of convergence. So this starts off with a ratio test. Okay, so let's do a ratio test here. Limit as n goes to infinity, x plus 2 to the n plus 1 over n plus 1 times 3 to the n plus 1 divided by an, or multiplied by the reciprocal, n, 3 to the n over x plus 2 to the n. Okay, here we split it apart. X plus 2 times x plus 2 to the n, n plus 1, and then this will be times 3 times 3 to the n. Here comes the favorite part again. We get to cancel 3 to the n's, x plus 2 to the n's. Okay, so let's take a look at what's left. Limit as n goes to infinity. we would have x plus 2 over 3 times n over n plus 1. I like to group the n's together to see what the limit turns out to be. If we just divide by n, we get a 1 over 1. This will be 0. 1 over 1, so that's going to be it for our limit, so 1. So that means we're left with just x plus 2 over 3, and our condition for convergence has to be less than 1. Okay, we can multiply by 3 both sides. We have absolute value x plus 2 less than 3. Set it up as a compound conditional, a compound inequality, I should say. This is less than 3, less than on the other side, negative 3. And now we can subtract 2 to all 3 sides. Negative 3 minus 2 is negative 5, less than x, less than 1. Okay, so those are our endpoints. We just have to test them now to make sure that we have any convergence or divergence, etc. Okay, so when x equals negative 5, we go back to the original series, plug in negative 5 for x. So summation negative 5 plus 2 to the n over n times 3 to the n. That gives us negative 3 to the n over n 3 to the n. We can cancel the 3 to the n, so we have summation negative 1 to the n over n. Okay, so it looks like we have an alternating series there. So we could use an alternating series test. Our term, our un would be just 1 over n. So remember, you would take the term that would be without the negative 1, or without the coefficient that's going to flip-flop it between negative and positive. Okay, so the un is 1 over n. So looking at that, would the u's be positive? Would the terms be positive? Yes. Would the terms be non-increasing? We're just following the alternating series test here. Yes, right? We'd have 1 over 1, 1 over 2, 1 over 3, 1 over 4, etc. Right? Non-increasing. And then with the limit as n goes to infinity of 1 over n, what would that be? Would it be 0? Right? Limit of 1 over infinity would be 0. Okay, so therefore we would say, using alternating series test, converges conditionally. Okay, let's test the other endpoint. When x equals 1, we have summation of 1 plus 2 to the n over n times 3 to the n. So that gives us summation 3 to the n over n 3 to the n. Cancel the 3 to the n's. So So we get a summation of 1 over n. Okay, so we know this series diverges. This is a harmonic series, p series, when p is 1. Okay, so therefore we know that this one we could include because it converges there. This one we don't include. Okay, so therefore we could write our interval of convergence. It will be -5 to 1. Include the -5, don't include the 1. And then our radius of convergence, -5 to 1 would be a distance of 6. That's like a diameter. Take half of that distance, so our radius of convergence is 3. Okay, let's take a look at our next problem. Area of the polar region that lies inside the cardioid. Okay, so remember the cardioid would be two minus 2 cosine theta. So we're going to be sitting on the x, on the negative side of the x. 2 plus 2 would be 4. Two going up, 2 going down, and then 2 minus 2 would be 0. Okay, so we're finding the area of this shape. So our formula would be integral 1/2 of our formula r squared. So 2 minus 2 cosine theta squared d theta. And we would be going from 0 to 2 pi. Right, we go 0 to 2 pi at 0, and then we go all the way around. Okay, so let's get started with it. We have integral 0 to 2 pi, 1/2, and then we're going to FOIL out the 2 minus 2 cosine theta. Okay, so that gives us 2 times 2 is 4 minus 4 cosine theta minus another 4 cosine theta would be minus 8 cosine theta plus 4 cosine squared theta. Okay, we could distribute the 1/2 into there. So that gives us 2 minus 4 cosine theta plus 2 cosine squared theta d theta. The only one we can't integrate directly is the 2 cosine squared theta. So instead of cosine squared, I will use our identity. 1 plus cosine of 2 theta over 2. We could replace cosine squared with. Okay, so we have 0 to 2 pi integral 2 minus 4 cosine theta plus 2 times 1 plus cosine of 2 theta over 2. Okay, so the 2's we could actually cancel those 2's. And so now we could combine the 1 with the 2, like terms. So that gives us 3 minus 4 cosine theta plus cosine of 2 theta and now we could integrate it term by term. So we have 3 theta minus 4 integral of cosine is sine plus integral of cosine sine, but to offset the 2 theta we have to multiply by a half, right? That would be a chain rule that we'd have to use there. And now we could plug in 2 pi, plug in 0, and then we could subtract. So we have 3 times 2 pi minus 4 sine of 2 pi plus 1/2 sine of 2 times 2 pi is 4 pi minus 3 times 0 minus 4 sine of 0 plus half of sine 2 times 0 is 0. Well, sine of 0 is 0. So this whole second part is 0. Sine of 4 pi is 0. Sine of 2 pi is 0. So the only thing we're left with is 6 pi. And that would be the final answer. Find the equation of the line tangent to the curve x equals 3 sine t, y equals 3 cosine t at the point t equals pi over 6. Originally I had pi over 2. Didn't work out nicely, so using pi over 6. Okay. So for parametric equations, remember we need to figure out, if we're going to figure out equation of a tangent line, we have to figure out the slope. The slope would be dy dx, but now remember dy is dy dt, and then dx is dx dt. Okay, so if we're figuring out the derivative of y, derivative of 3 cosine t, derivative of cosine is negative sine, so this will be negative 3 sine t. dx dt, derivative of sine is cosine, so this will be 3 cosine t. Okay, now we evaluate, this is our dy dx, evaluate it at pi over 6, so negative 3 sine pi over 6. Actually we could cancel out the 3's, right, because they're going to be gone. We could just have a negative sine of pi over 6. And then for a denominator, cosine of pi over 6. Okay, if you don't remember the cosine and the sine, you could draw your triangle. 30, 60, 90. We have 1, 2, square root 3. Okay, so pi over 6 is 30. So sine of 30 would be opposite over hypotenuse, so that would be negative 1/2. Our cosine of pi over 6 will be square root of 3 over 2. And so what does that turn into? We have negative 1/2 divided by this would be times the reciprocal. So that gives us 2's would cancel, negative 1 over square root 3, which we could rationalize negative square root 3 over 3. Okay, so that's our slope. dy dx, aka m, is negative root 3 over 3. Now we need an x and a y. Okay, so for the point pi over 6, okay, t is pi over 6. So to get our x, that would be 3 times sine of pi over 6. So that's 3 times 1/2, so 3/2. The y would be 3 times cosine of pi over 6. That's 3 times cosine square root 3 over 2. So that becomes 3 square root 3 over 2. Okay, so now we could use our point slope formula. And we can plug in our y1, which will be 3 root 3 over 2, and negative root 3 over 3, x minus x1, which will be 3 over 2. Okay, and now we could simplify it. We're going to distribute the negative root 3 over 3. So that gives us negative root 3 over 3x. Negative times negative is a positive. 3 root 3 over 6. Right, and we can actually reduce that. Reduce it. So that will give us root 3 over 2. Okay. So now, last step, we'll just move the 3 root 3 over 2. So we end up with negative root 3 over 3x plus we have 1 root 3 over 2 plus 3 root 3 over 2, so that's 4 root 3 over 2. And again we can reduce. So we would just have y equals negative root 3 over 3x plus 2 root 3. And then that would be it. That would be the equation of the line tangent to the curve at the point t equals pi over 6. Okay, well I hope this helps. Okay, you can rewatch the video to help you study. Okay, and hopefully this will help for our final exam for Calculus 2. Okay, have a great day, great night. Hope to see you soon.